Let us see about symmetrical lattice attenuator now. This is having the structure of lattice and it is symmetrical. You can see that upper resistance is RA, lower resistance is RA, and these diagonal resistors are RBs. So they are equal. So this is also a symmetrical attenuator, right? And what are the properties of symmetrical attenuator? When it is terminated with R0, the resistance seen from the input will also be R0, which is nothing but characteristic impedance, right? Okay, now let me rearrange this structure of lattice like a bridge here. Okay, you can see, let us say this is point A. If you start from here, point A, we have two resistors RA and RB. Okay, see, from point A, RB and RA are there. Okay, without changing anything, we are just rearranging the elements without changing any connection type. So once RA RB are there, at the end terminal of RA we have RB and R0. Okay, so let us see, at end of RA we have R0 and RB. Yes, that is satisfied. Similarly, then again for this RB end we have RA and R0, right? So here also at the end of RB we have R0 and RA. So this is how we can rearrange the elements for better analysis. Okay, so what we need to do next? Here also we have two unknowns for designing of lattice attenuator, that is RA and RB. In terms of what we need to do that, in terms of R0 as well as I1 by I2 ratio we have to do. So for that, in this case we don't need to determine Z0, even though it is determined here. This part is not required. Okay, let us move ahead. So what we are doing here, directly we are going to determine I1 by I2 ratio, which is an important ratio for getting attenuation. And how to determine this? We of course need to go for mesh analysis, but where? There are many loops here, right? So in order to get I1 by I2 ratio in terms of RA and R0, we have to consider the loop of A, B, C, D, E, A. Okay, let us see where are those alphabets. A is here, A, B, and then C, and then D. We are not moving to C, E. From C to D we are going, from D to E, and then the circuit will be closed, and that path is indicated in this red color. Okay, so in that path we have to apply mesh analysis, right? So how many elements are there? We have RA, R0, RA. That means RB is eliminated from this path. This is how we have chosen that loop intentionally, so that we will have only R0 and RA, and directly we will get the ratio I1 by I2. Okay, along with these three we have V1. And what is V1? V1 is nothing but R0 into I1, right? Okay, using that we will be getting this equation, minus I1 R0 plus RA into I1 minus I. So what is this I here? We have introduced one current variable I, which is flowing through RB. When I1 is coming, I is leaving. What is the current flowing through RA? It will be I1 minus I. Okay, so when I1 minus I is coming, and we all know R0, this current is I2 from the given circuit diagram, right? So I2 is coming, this I is coming, again this current will be I plus I2. Similarly, when you add these two, this current will be coming, that is I1 minus I plus I2. Okay, that current is flowing through RB. Okay, fine. So we will get that equation, KVL equation. Then when you simplify, you will get the ratio of I1 by I2, which is already considered as capital N. So you will get it as 1 plus RA by R0 by 1 minus RA by R0. So from this what we can do, if you take N minus 1 by N plus 1, it will be coming as the ratio of RA by R0. And what is unknown here? RA for designing the attenuator. So we need to write RA is equal to R0 into N minus 1 by N plus 1. That's it. It is easy to get here. So remember, we have not even used R0 expression here. Directly from a proper loop where RB is eliminated, we got RA. So similarly now for getting RB we have to eliminate RA in the loop, right? So to eliminate, what we have to proceed, we have to consider the loop of A, B. Then since RA is already determined, we just go into this side RB. So now from A, B, D to C, E we can proceed, right? So we can apply the KVL in this loop now. So when you apply that loop, if you consider, you will be getting RB is equal to also R naught into n plus 1 by n minus 1. Just these two are interchanged, the ratio. Numerator become denominator, denominator has become numerator. So this is how you can get easily RA and RB. With that you can design what? Lattice attenuator. Okay. So this is how we can even design one more attenuator, which is lattice attenuator. It is generally considered as like it is a general type of symmetrical and balanced network, right? Because both diagonal elements are there and upside downside elements are also there. From this you can either structure pi network as well as T network by considering one of the resistance as 0 or infinity. So that's why this is considered as general type of symmetrical and balanced network. Okay, that's it. Thank you.